Again, welcome to Python programming language. This is the conclusion of chapter 2 of our course textbook, which is Introduction to Turtle Graphics. This is a special Python graphical user interface package, library package. So our main objective is Introduction to Turtle Graphics, that's Python graphical user interface. So here we say Python's turtle graphics system displays a small cursor known as turtle. So this is how it is, a small cursor. Now we can move this cursor in any direction we want, whether left, right, up, down. By doing that, again, we can draw different types of images. So here we say we can use the Python statement to move the turtle around the screen, drawing lines and different types of shapes. So again, to use the turtle graphics system, the first thing we need to do is to import the turtle package. So the keyword import and the name of the library file, turtle. So this will load the turtle module into our memory. Then from there, we can start to write our statements. So first example is we are going to use the turtle.forward. And n will be the distance or the number of pixels I will use, the correct number of pixels. Statement to move the turtle forward, the number of pixels. So more or less a distance. So for example, here, first thing we do is to import the turtle. Then we have turtle.forward 100. So this means we are moving forward from the center. Normally the cursor, which we call the turtle, will be at the center of the window. So we can see in the beginning, and this is our turtle in the center. So we can move any direction by drawing any type of image. So here we are going to draw a line, which is 100 pixels, the distance. So again, running this code, we're going to get the image we have, 100 forward. Then next, the turtle's initial heading is 0 degrees. So for example, here we can use turtle.right angle. The angle can be 90 degree, 45 is up to us. So turtle.right, argument of the angle statement to turn the turtle right by the angles that we have. Also, we can use the turtle.left angle statement to turn the turtle left by an angle and degrees. Again, can be any angle, 45, 30, any. We know the highest we can go is 360, a circle. 180 is straight. So let's see the example here. So we already have the turtle.forward, which gave us the line, horizontal line. So next we say turtle.left 90. So we are going to have a 90. Left will go up and right will go down. So here we say turtle.left 90. So the direction will be up. But the distance or the number of pixels, we have forward 100 again. Again, can be any number of pixels. So we can see at beginning, we have a forward 100, which is our horizontal line. Then the left 90, change the direction of the turtle to up by 90 degrees, as we can see the intersection, 90 degrees. Then we want to move 100 pixels, so we go up to 100. Then next, we have another one. We still have our forward 100, the second statement, which gives us the horizontal line. But this time we are doing right 45. So we can see we go down by 45 degrees because we are here. So from here to down is 45 degrees. 90 degrees should be a vertical down. Then the distance again is 100, so forward 100. So we have 100 down by angle of 45 degrees. The angle will be, again, the horizontal line. Then we draw it down towards right where my cursor is going. So the other side from left is more than even 90 degrees. So it's 180, so 180 minus 45, that will give us 135 degrees down. So next also we can use the set heading. And when we set the heading, we can specify the angle also. So the set heading angle statement is to set the turtle's heading to a specific angle. So instead of using right, left to the angle, we can just use the set heading 90. So again, we start with importing the turtle. The first we do forward 50. So forward 50 will be horizontal line at the bottom 50. Then we say set heading 90. So the direction go up 90, but it's forward 100. So we go up. So we go 100 up, set heading 90. Then we have forward 100. Then after that, we also have a set heading 180. So we have 180. Then we go forward for 50. Then set heading 270 will go down. Then 100 to the down. So we can see how the set heading works. So we can see 90, it goes from the horizontal, then it will go towards left. So 90, then 270, or 180 will be straight, then 270, then 360 will be back to the same position. So let's go through one more time. First of all, we import our turtle. When we import the turtle and we start, the cursor will be in the center, which is we call the turtle in the center. So forward 50 means we go towards right for 50 pixels. Then we set the heading 90 degrees, so the direction will go up 90 with the 2. Then we set forward 100, so we reach here. Then we set 180 will be horizontal, so this will give us 180, and the distance again, or the number of pixels is 50. Then we set heading 270. So 180 plus 90 will be 270, so that will be 90 again. Then the distance is 100, so we come back to the same point. So again, set the heading takes argument of an angle, and it gives us the direction of the angle. It can be any angle from 0 to 360. So next, we are going to set the pen up or down. Now, when the turtle's pen is down, which is by default, the turtle will draw a line. But when it's up, by default again, it's down. But when it's up, the turtle does not draw a line. So for example, if I want to draw a dash, a line, space, then I'll know when to have it up, how long I want to go, the number of pesos. Then when I want to have a space, I will also specify the number of pesos for the space. So here we can have turtle.pen up. So this means we raise the pen up, so we are not going to draw anything. The turtle.pen down statement to lower the pen, then we draw. So let's see an example here. Again, we import the turtle, we have our first 50 from the center is 50. But now, again, as we said, by default, the pen is always down. So when we want to, again, draw a line for 50 pesos, again, we don't have to say pen. Unless the pen is already up, then we say pen down. We don't need to say pen down. By default, it's already down. So here we have 50, then we move the pen up, then we have no more pesos, 25. So that's the dash space 25. Then we put the pen down. Since the pen is up, we have to now use pen down. Then we draw a line, 50, the same angle. So we have a second. Then we move the pen up, then we have 25 space again. Then now we move the pen down, then we draw 50 again. So we have 2 dashes between, which when we move the pen up, and we forward 25, then it will be dash. Also, we can use the turtle.circle to draw a circle. The argument will be the radius. So here, for example, we import the package again, turtle, then we say turtle.circle 100. So this will give us a circle with the radius as 100. So this is a radius of 100 circle. Also, we can draw a dot. So we can use turtle.dot statement to draw a simple dot at the turtle's current location. So when we import the turtle package, first thing we have is turtle.dot. So this means the center will be a dot beginning. Then we'll move forward for 50. Then we draw another dot again. We move forward for 50. We have another dot. And we move forward 50, and that's the end. So again, import the package, turtle. We draw a dot. We move forward 50 pesos. Draw another dot. We move forward 50 pesos. Then we have our, again, dot again. So now we also have a special function called the pensize that will give us the thickness of the shape, whatever shape we are drawing. And also we can have a pen color to change. Previously, all our drawings are, again, as we can see, it's just a black and default regular. But now you can see we have import turtle. We change the size to 5 to make it a little bit thicker. Then we change the pen color to red before we draw the circle. So the two things we are doing here is that we are changing the thickness of the line, which is the pen size. Then also we want the pen to be red color. Then we draw whatever image we want. In this case, we want circle. Now, our textbook Appendix D gave us the complete list of colors. Or again, you can Google it. If you Google, you get it. Now, we can also work with Turtle's window. For example, the first is to change the background color. So here, when we say turtle.bg, which is background color, the argument will be whatever color we want to. Also, we can set the window size. So turtle.setup, we set the width and the height of the window. Again, we have a default size, but we can change the size in it. So for example, here we say import turtle, then turtle.setup. We are changing the size to be 640 by 480. So the width will be 640, the height will be 480. Now we can also reset the turtle's window. We have a reset statement. Normally, a reset statement will erase all the drawings that currently appear in the window. So more or less like deleting all the images that we have, or the drawings, the shapes we have. And it will reset the drawing color to black, the pen color to black. Also, it will reset the turtle to its original position. That means the cursor will be at the center of the window, but does not reset the graphics window background color. So whatever background you set, you're going to have it. We also have the turtle.cre statement. Also, cre statement, or we can say the cre function, it erases all drawings that currently appear in the graphics window, but it doesn't change the turtle's position. Unlike reset will put the cursor. The cursor is what we call the turtle. It will put it in the center. Also does not change the drawing color, but again, reset changes the drawing color. And also do not change the graphics Windows background color. So the same thing applies to turtle.reset. It doesn't change the Windows background color. We also have turtle.cre screen. So this normally will erase all the drawings that currently appear in the graphics window. Also, it's going to reset the drawing color to black. And this time it's going to reset the turtle to its original position in the center of the screen, same as the reset. But the difference is that with the cre screen, it's going to reset the graphics window background color to white. So anytime we want to have a default background color to white, we use the cre screen method or function. If we don't care about the back, we want to leave the background color as it is, then we can use reset. But if we want to delete all the drawings on the screen, but we don't want to change the position of the turtle or the pen color or the background color, then we can just use the clear method or function. So we can also, one thing again, this is more or less a graphics. So we can see a 90 degree to 70, etc., 45. So which gives us the idea of in a college algebra, we have something called the coordinates or computer graphics. So here we know everything here is 360. So if I'm in X plus, S is plus, and Y is minus, then we'll be in the fourth quadrant. In the first quadrant, Y and X is positive. In the second quadrant, S is negative, Y is positive. In the third quadrant, S is negative, Y is negative. So Turtle also use the Cartesian coordinates. This is same as in the college algebra concept. We use first, second, third, and fourth quadrant. The position of the quadrant depends on the sign of the coordinates S and Y. So this example here, we can use go to X and Y statement to move the turtle to a specific location. So for example, here we import the turtle. We use turtle.goto 0 and 100. So that's the first space 0, 100. Then we have go to negative 100 and 0. So remember, the first value is our X. The first value is our X. So S will be negative 100 pesos and Y will be again 0. So Y will not to be vertical. Then we also have turtle.goto 0, 0. This will be the, actually that will be the end to come back to center of origin. As we can see here, the center of origin is 0, 0. So if turtle is negative 100 to 0, it means we are in this quadrant here on the left side, which will be our second quadrant. Y is 0, it's positive, X is negative. So that's why we can see the diagram. First 0 and 100, which will be vertical because Y is again 100 pesos, X is 0, stay in the same position. Same. Then we have negative 100 for X, but Y is 0. So negative 100, Y is 0. You can see Y now, we are in the center of origin. Y now is already 0. S is negative 100. Then 0, 0, we come back to the center of origin. So here we say turtle.positive or turtle.pos is a statement that displays the turtle's current S and Y. I mean to say position. Turtle.position statement displays the turtle's current S and Y coordinates. And turtle.s COR, or I'll say S coordinate, will display the turtle current S coordinate. And turtle.y coordinate, or YCOR function statement display the turtle's current Y coordinate. So right now, for example, we can see where the arrow is, that is the location of the turtle. So right now, that's the last section. The X is 0, Y also is 0. Also, if we want to do animation speed, again, we may run a program and we will see that the line is again moving in a specific speed, more like an animation. Turtle gives us a function named speed that make it possible. So we say use the turtle.speed, and the argument will be the speed, the rate of the speed. And this is a command to change the speed at which the turtle moves. So the speed argument is a number in the range of 0 through 10. So if you specify 0, then the turtle will make all of its moves instantly. So there's no animation. And that's what we'll be doing by default. You write the image, then when you run the program, the image will show. Also, we can hide and display we can also hide and display the turtle. So for example, if I want to hide a turtle, just use hide turtle function. So turtle.hide turtle command to hide a turtle. This command does not change the way graphics are drawn, but it simply hide it. So any command for drawing forward, moving, angles, to do everything, by again, it's going to hide the turtle, you will see it. And also we can use show turtle function command to display the turtle also. We can also display a text, which we use the method name write, then whatever text as the argument. So here we say turtle.write the text, the statement to display the text in the turtle graphics window. So again, the text argument will be a string that you want to display. The lower left corner of the first character will be positioned at the turtle X and Y coordinate. So this example here, we have import turtle, then we say turtle.write hello world. So here we just want to display text hello world. Importing the turtle will give us the window. So that's the main thing. We need our window. Now, in a console application, we use the print to print item on the screen. By its console, here we are creating a window. Then we have a statement on it. So this is more or less again graphical user interface. So turtle.write hello world will write hello world. Now here we don't have no position anything, so it will start from the center. So hello world will start where the cursor is by default always at the center. Also, we can fill in shapes, more or less like painting a shape or an object. So here we can use turtle.begin fill. Begin fill function is a command before drawing the shape. Then turtle.end fill will be the command after the shape is drawn. So when the turtle.end fill command is executed, the shape will be filled with the current fill color, whatever color we specify. So let's see an example here. We already have our circle. So remember, we have the import turtle. Now here we want to see a nice image. We don't want to see the arrow or the cursor on top of the image. So we hide the turtle. So after we hide the turtle, we have a fill color red. So it can be any color you want to use. Then we also start to begin fill. So this means our cursor the turtle is ready. We hide it, we change it to red, then we fill it with fill method to fill it. So what the image it will be is a circle. So after we draw the circle, by default, we fill it with red. After finish, we have to end the fill. Then we can start. Now, keeping the graphics window open, here we say that when running a turtle graphics program outside the idle, the graphics window closes immediately when the program is done. So anytime you run your program finish, when it finish, the window will be closed. So to prevent this, we always have had the turtle.down statement to the very end of your turtle graphics. So after you write or your statement finish, you end it with turtle.down. And what this will do is that it will cause the graphics window to remain open. So you can see its content after, for example, finishing drawing your image, you can see it. Other than that, it will show the image in the second, then it will close. The window will close. So this will be the summary of our lectures. Again, in these lectures, we discuss some few features of turtle graphics system, and this is the beginning introduction. As time goes on in the next chapter, we shall use the package, the turtle package, to do more complex diagrams. So again, wish everybody the best. If you have any question about these lectures, again, you can send an email, or when we meet in class, we can discuss it. Thank you.